Right now you are surrounded by a world you cannot see, hear, or touch. A world of silent, pulsing energy that flows through every living cell. You are blind to it. But for a shark, a platypus, or a tiny fish in the Amazon, this invisible world is as bright as a neon sign. What if I told you that some animals can literally read your mind, or at least the electrical sparks that create your thoughts? We perceive the world through a narrow slit of reality. We see light, we hear vibrations, we smell chemicals. But we are missing the sixth sense. It's called electroreception. It's the ability to detect the bioelectric fields generated by all living things. Every time a muscle twitches, every time a heart beats, and every time a neuron fires, it creates a tiny electrical disturbance in the surrounding environment. To us, a fish buried under 6 inches of sand is invisible. To a hammerhead shark, that fish is screaming in high-voltage color. But how does a biological creature turn into a living voltmeter? And why did evolution take some animals down a path so alien that we've only just begun to decode their language? Today, we're going beyond sight. We're diving into the hidden electrical ocean to meet the masters of the invisible hunt. And by the end of this video, you'll realize that the most alien life forms on Earth aren't in space, they're right here, and they can sense your heartbeat from a mile away. If you look closely at the snout of a shark, you'll see hundreds of tiny black pores. For decades, scientists thought these were just mucus glands or perhaps some kind of weird taste bud. It wasn't until the 1960s that a researcher named Stefano Lorenzini realized these weren't just holes, they were the most sensitive electrical sensors in the known universe. They are called the Ampullae of Lorenzini. Inside each pore is a long, jelly-filled tube that leads to a specialized bulb. This jelly is incredible. It is one of the most conductive biological materials ever discovered. It acts like a high-speed fiber optic cable for electricity. Here is the science that will melt your brain. A shark can detect a voltage gradient as small as 5 billionths of a volt per centimeter. To put that in perspective, imagine you took 2 AA batteries and connected them to electrodes placed 1,000 miles apart. A shark in the middle could tell when you turned them on. This allows them to see the tiny electrical pulse of a shrimp's heart or the nerve impulses of a flounder hiding in the dark. Have you ever wondered why the hammerhead shark has such a bizarre shape? It's not for swimming, it's for sensing. Their wide, flat heads act like a giant metal detector. By spreading those sensors across a wider area, they get a stereo view of the electrical world. But sharks aren't even the most impressive ones. There's a creature that doesn't just detect electricity, it uses it to create a private, high-speed internet that no other species can hack. But before we get to the social media of fish, we have to talk about the world's weirdest mammal. When British scientists first saw a preserved platypus specimen in 1799, they thought it was a hoax. A duck's bill sewn onto a beaver's body? It was a joke. But the real joke was on the scientists. The platypus is a biological masterpiece, and its greatest secret is its bill. When a platypus dives underwater to hunt, it does something that would be suicide for any other predator. It closes its eyes, its ears, and its nostrils. It is effectively blind, deaf, and unable to smell. So how does it find tiny shrimp in the pitch-black mud of a riverbed? The bill of a platypus is covered in 40,000 pushrod mechanoreceptors and nearly 60,000 electroreceptors. It is the only mammal aside from a few species of dolphins that has mastered this sixth sense. As it wiggles its bill back and forth, a movement called saccadic searching, it's mapping the electrical field of the river. When a shrimp flickers its tail, it creates 2 signals, a physical pressure wave and an electrical pulse. Because electricity travels through water faster than a pressure wave, the platypus sees the electrical spark first, then feels the thump of the water a millisecond later. By calculating the time difference between the two, the platypus can triangulate the exact distance and speed of its prey. It's like a biological version of seeing lightning and then hearing thunder to figure out how far away a storm is. But if the platypus is using electricity to find food, what happens when it encounters something that is electricity? Scientists didn't expect this, but the results were terrifyingly efficient. So far, we've talked about passive electroreception, listening to the world's energy. But what if you could scream in electricity? Welcome to the world of active electroreception. This is the electric eel. Fun fact, it's not actually an eel. It's a type of knifefish, and it is a living battery. About 80% of its body is made of specialized cells called electrocytes. Individually, they produce a tiny charge. But when the eel fires them all at once in a series, they produce a massive discharge of up to 860 volts. That is enough to stop a human heart or knock a horse off its feet. But the eel doesn't just use this as a weapon. It uses it as a flashlight. It emits low-voltage pulses, think of it like sonar, but instead of sound bouncing back, the eel feels how its own electrical field is distorted by objects around it. If a rock is in the way, the field lines bend. If a fish is nearby, the field lines are sucked in. The eel feels its environment through its skin. But here is where it gets truly wild. Deep in the Amazon, there are weakly electric fish. These fish don't have enough power to shock you, but they use electricity for something even more complex: conversation. Imagine living in a world where you are constantly humming a specific note. If you meet someone humming a different note, you can talk. But if they hum the same note, your signals clash. You can't see anymore. This is the jamming avoidance response. When two electric fish with similar frequencies meet, they both instantly shift their frequencies. One goes higher, one goes lower, so they don't drown each other out. It's the most sophisticated wireless network in the animal kingdom. They use these pulses to signal their sex, their age, their dominance, and even their emotional state. They are literally texting each other through the water. Scientists have discovered that these fish can remember the specific electrical signature of their neighbors. They know who is a friend and who is a stranger just by the flavor of the electricity in the water. But wait, if water is the perfect conductor for this sense, does that mean land animals are left in the dark? Not exactly. For a long time, we thought electroreception was limited to water because air is a terrible conductor. But nature finds a way. Meet the bumblebee. As a bee flies through the air, it bumps into dust and air molecules, which strips away electrons. By the time the bee reaches a flower, it has a positive static charge. Flowers, on the other hand, are grounded and tend to have a negative charge. When a bee approaches, the flower's electrical field actually pulls the bee's hair toward it. The bee can feel the flower's charge before it ever touches the petal. Even more incredible? Once a bee visits a flower and takes the nectar, the flower's charge changes. Other bees flying by can sense that the electric sign says, "Closed for lunch," and they fly past to find a flower that hasn't been drained yet. They are reading a biological neon sign that we can't see. This leads us to a fascinating question. If animals can do this, why can't we? Actually, we're trying. Scientists are currently developing bio-integrated sensors that could give humans electrovision. Imagine being an electrician who can feel a live wire through a wall, or a search and rescue diver who can sense a survivor's heartbeat through 20 feet of mud. We are on the verge of hacking our own biology to unlock the sixth sense that evolution denied us. Understanding electroreception changes everything we know about life. It proves that reality is a subjective term. To a shark, the ocean isn't a vast blue void, it's a vibrating web of energy. To an electric fish, the dark river isn't silent, it's a loud, buzzing conversation. To a bee, a garden isn't just a collection of colors, it's a glowing map of electrical signals. We often think of ourselves as the masters of perception, but we are actually tuned to a very specific, very limited frequency. There are entire dimensions of communication and survival happening right under our noses, and we've been blind to them for thousands of years. The next time you look at the ocean or a field of flowers, remember, you're only seeing the surface. Beneath the visible world, there is a hidden symphony. A pulse, a spark, a world beyond sight. If you could have one animal superpower, would it be the shark's electrical, radar, or the bee's ability to sense the energy of a flower? Let me know in the comments below, I read every single one. If this video zapped your brain in the best way possible, hit that like button and subscribe. We're on a mission to uncover the most mind-blowing secrets of the natural world, and you don't want to miss what we're diving into next. Speaking of invisible worlds, did you know there are animals that see colors humans can't even imagine? Click here to watch our documentary on the mantis shrimp, the creature with 16 color receptors. Stay curious. I'll see you in the next one.